In this short video I'm going to rattle through some very quick revision of Ohm's law and resistors in series and parallel. So here we've got a very simple circuit. The one unknown is the voltage required if we've got 30 milliamps of current flowing through the circuit and a resistance of 400 ohms. So what we would do there is we would write out the formula V equals I times R. V is equal to 30 milliamps, that becomes 0.03, or you could put milliamps into your calculator, times the resistance of 400 ohms. So the voltage would equal, when I type that into my calculator, works out to be 12 volts. This next circuit, we would describe those two resistors as being in series. To work out the total resistance when they're in series, we would do RT is equal to R1 plus R2, which obviously don't need to do much maths there to work that out. It's 500 ohms. And then again we could use, so those two resistors, the combined effect of both of them, 500 ohms, we could work out the current that's flowing through the circuit by doing exactly the same as before, but using Ohm's law. I equals V over R this time. I is equal to V, which is 12, divided by the 500 ohms. So the current which is flowing in this circuit would be, when I type that into my calculator, 0.024 amps, or 24 milliamps if you want to put it that way. Over on to this question. Here you would describe where the wires branch off and go in different directions. You would describe this as a parallel circuit. And this one here, I'm going to show you the one method for calculating the combined effect of the two resistors in parallel, but only works when we've got two resistors. R1 times R2 divided by R1 plus R2. So we plug our numbers in there. So the resistance total would be 100 times 200 divided by 100 plus 200, which again, when I type that into my calculator, these two resistors together in parallel, they have a combined effect of 66.6 ohms. Finally, if you have if you have three resistors in parallel, you can't use this formula. You could use that formula and just treat two of them, and then you would need to do that same formula again with the combination of that one and then that one. That's another step. That's not the way I would do it. This formula is in your data booklet as well. Resistance total is 1 over R1 plus 1 over R2 plus 1 over R3, and it goes on for 4 resistors, 5 resistors, and so on. What we then do is plug in the numbers. 1 over RT is 1 over 100 plus 1 over 120 plus 1 over 160, and just for easiness I've already worked this out. So RT is equal to 1 over, and you can type all that stuff into your calculator, 0.01 plus 0.0083 plus 0.00625. I'm running out of paper here. RT therefore equals 40.73 ohms.